In this example, we will anti-differentiate x cubed multiplied by the square root of x minus 1. So the intuition looking at this, no obvious algebraic simplifications or manipulations that we can see. But in terms of substitutions, there's maybe an obvious choice of a substitution to attempt, this inside function that we see, the x minus 1. So let's see if this can work out. So if u is equal to x minus 1, du would be equal to dx, but that leaves us this extra x cubed term in the integrand that we have to rewrite in terms of u's. And the general procedure for doing so is to go back to the substitution itself. If you ever have any leftover x's, remember that the substitution expresses the relationship between u and x. So simplifying this, x is u plus 1. So now we see that everything should work out quite well. X cubed is going to become u plus 1 cubed, and the x minus 1 underneath the square root is what we set equal to u. So square root u du. And now if we do a bit of algebra, that is expand out the u plus 1 quantity cubed, rewrite square root u as u to the 1/2, we can get this integrand solely in terms of powers of u, which is ideal for anti-differentiation. So let's see here. If you were to expand out u plus 1 quantity cubed, that would be u cubed plus 3u squared plus 3u plus 1. And this is all multiplied by u to the 1/2 power. So now distributing this through, we'll have u raised to the 7/2 plus 3u raised to the 5/2 plus 3u raised to the 3/2 plus u to the 1/2. And now we really are in an ideal position. Anti-differentiating u to a power is about as good as it can get for us. So the antiderivative of u to the 7/2 is 2/9 u to the 9/2 plus 3 times the antiderivative of u to the 5/2. So that would be 2/7 u to the 7/2 plus 3 times the antiderivative of u to the 3/2, which would be 2/5 u to the 5/2 plus the antiderivative of u to the 1/2, 2/3 u to the 3/2 plus c. And as with any substitution, our last step is we have to get back in terms of that original variable x, and we do so by just replacing every u that we see with an x minus 1. So resubstituting and kind of combining terms as we go. So 6/7 x minus 1 to the 7/2 plus 6/5 times x minus 1 to the 5/2 plus 2/3 x minus 1 to the 3/2, all plus c.